In this video, we'll explore decimals and negative numbers in the base 10 system. Now, in the base 10 system, it's structured so that each place value is 10 times that of the place values to its left and right. For instance, if I'm in the ones place, the tenths place is 10 times greater than the ones place, and the tenths place is 10 times smaller than the ones place. So that decimal point is going to help us indicate where the ones place is. The decimal is always to the right of the ones place. So when we talk about decimal notation, we're talking about any string of digits, whether or not there's a decimal place there. And it can be an infinite number of digits as well. So if I write 427 as 427, that's decimal notation even though I don't include that decimal point. But if I have 427 and 35 hundredths, again, that's decimal notation if I write it with that decimal point. A great way to think about the decimal system is with money, because we can actually think about the tenths being our dimes and the hundredths being our pennies. And that's a very great way for students to understand the different place values. So if I have 47 and 26 hundredths, that means I have 4 tens, 7 ones, 2 tenths, and 6 hundredths. Now when I say and write decimals, it is extremely important that I pay attention to the way I enunciate words and that I pay attention to where that decimal place is. The decimal place makes the number system symmetric around the ones place. Now remember that because that's important. It's around the ones place. Many people think it's around the decimal, but no, it is around the ones place. So to the left of the ones place is the tens. To the right is the tenths. And then the hundreds, the hundredths. So you got to pay very close attention to whether it's ending in, say, like just an S or a THS. So if I had the number 2.34, that is 2 and 34 hundredths. Now when I want to plot numbers on the number line, I still have it so it's located in units away from 0. So one way I can consider doing it is using the number line in a stage approach, where I'm going to actually use the notion of the base 10 system to help me get down to the very exact location of where that number is on the number line. The big thing to remember is that our primary and secondary tick marks are going to follow that base 10 system. So here I have 1 in 738 thousandths. So if I start with just a general number line, my major tick marks are ones. That means each of my minor tick marks are tenths, because that's the next smallest in the base 10 system. And I know that this number would be somewhere between 1 and 7 tenths and 1 and 8 tenths. I'll put a point there. Now what I'm going to do is zoom in between those two tick marks. What this means, and see there, I have that, the 7 tenths and the 8 tenths. Now I'm going to zoom in again between the 7 tenths and the 8 tenths. And what this means now is that my major tick marks are the tenths, so my minor tick marks are now the hundredths. So when I look at 1 in 738 thousandths, that means I have 73 hundredths and then 8 thousandths. So I'm somewhere between 73 hundredths and 74 hundredths, as you can see here. Now I want to zoom in again so that I can get that exact value on the number line. So I'm going to be looking at 73 hundredths and 74 hundredths as my primary tick marks. Then I have to say, well, what would be the next in my base 10 system? If these are hundredths, I zoom in and now my minor tick marks are thousandths. So I now have 731 thousandths, 732 thousandths, on and on and on, up to 739 thousandths. And if I wanted to, I could say this as 740 thousandths. So now I can plot that point exactly where it belongs at 1 in 738 thousandths. Now with negative numbers, these are numbers that are less than 0, and they're an equidistant from 0 as their positive value in. For example, if I have negative 2 and 41 hundredths, that's 2 and 41 hundredths to the left of 0 instead of to the right. And if I wanted to put that on a number line, I could start at 0, and I could skip over. I go 1 to the left, 41 hundredths to the left, and there I'd put my point. And if that had been a positive 2 and 41 hundredths, it would have been over in this area, but they'd be equal distance from 0. One way that we often talk about this is the notion of owing money, or maybe a temperature below 0, elevations below 0. All those are ways that we can think about negative numbers. So when you see negative 25 degrees Fahrenheit, that means it's 25 degrees below 0. If I owed you $25, that'd be like negative 25.